Hi, this is Miss Ball, and today we're going to be talking about enzymes. And this is the last big piece of information that you're getting for your biochemistry unit. So as I go through the video, feel free to pause and write down notes, or you can watch the whole thing through and go back and add to your brain dump sheet. We couldn't survive without enzymes. They're essential to keeping all of the chemistry working inside of our bodies. Enzymes are catalysts because they reduce the energy needed to get a reaction going. This is called activation energy. Enzymes are usually, almost always, special large proteins that act as catalysts for living organisms. And a single organism could have thousands of different types of enzymes based on the different types of reactions that happen in our body. There are a few exceptions to the protein rule, but we won't really worry about those today. Enzymes reduce the energy needed to get a chemical reaction started, which also makes those reactions happen at a faster rate. Without enzymes, all of the chemical reactions that take place in your body would happen too slowly, and you would not be able to function. Enzymes are reusable molecules. They do their job, and then they are ready to do more work. The general term for the molecule they break down is called a substrate. For example, lactose, the disaccharide found in dairy products, or double sugar, is a substrate. When we eat, our digestive enzymes help to break down our food. Lactose is broken down with the enzyme lactase, and the products of lactose are the single sugars, glucose and galactose. And then that enzyme lactase can go on and break down even more lactose molecules after it does its job. Enzymes don't always have a perfect fit with their substrate, like a lock and key fit together, but when they meet up, they bind and form a fit so that the enzyme can do its work of breaking the substrate down into products. Just like the ending ose tells you that a biomolecule is a sugar, the ending ase usually tells you that the molecule is an enzyme. Try figuring out the names of these enzymes. So the enzyme that breaks down lipids is called lipase. The enzyme that breaks down lactose is lactase. And the enzyme in your saliva that breaks down starches that are found in things like breads and crackers is called amylase. So when we put all of this together, we start to realize that the enzyme lactase is necessary to break down the disaccharide lactose, and it breaks it down into two single sugars or monosaccharides called galactose and glucose. Both of those monosaccharides are easily digested by most people. Notice that enzymes have a sweet spot for best performance. If the environment's too cold, enzymes may be too slow to work. The graph shows us that when enzymes get too hot, they quickly quit working. But the ideal conditions for an enzyme depends on the normal conditions for the organism in which they are found. An example of a thermophile or heat lover would be bacteria found living in hot springs. Proteins are really sensitive to heat, and they may make a permanent shape change if they are exposed to heat. For example, in this picture, we see an egg white which is full of proteins, and it changes from a liquid to a solid state when the proteins are broken and unfolded by the heat. And you can't just cool an egg down in the fridge and reverse the chemical change because it's a chemical change. Similarly, when enzymes are heated, since most of them are proteins and sensitive to heat, their shape may be changed and they may not be able to do their job anymore because their substrates won't fit correctly. So, how are enzymes applicable to our daily lives? Well, we use them in industry for production of products that we use in our houses. They're used to make alcohol, cheese, beauty products, cleaning products, and even your stonewashed jeans are created using enzymes. We use them in medicine for different types of therapies and treatments. And in your body, you're using enzymes every day, all day, for all the chemical reactions that take place inside your body. For example, there are people who lack certain enzymes, and we call them lactose intolerant, and it's an example in which the lactose enzymes don't function or are not properly being made. So, if you don't have lactase or you don't have enough lactase, then you might suffer a condition called lactose maldigestion. So, if you don't have enough of the enzyme, then the lactose from the milk is sitting in your gut tract or your small intestine, and it sits there undigested, and it feeds certain bacteria, which create gas and just kind of make you feel yucky. And if you have just a little bit of lactose maldigestion, it may not be a problem. But people who have a lot of lactose maldigestion will suffer digestive symptoms called lactose intolerance. And those symptoms could include bloating, cramps, vomiting, diarrhea, or gas. So, lots of people live with lactose intolerance. Some of them just suffer through it. Some of them try using dietary aids, such as this Lactaid you see in the picture. These little pills are laced with lactase to help people digest their food properly. And you may be thinking, well, I don't have this problem. Well, you don't yet, but a lot of you may eventually have some level of lactose intolerance. Approximately 65% of humans have some type of lactose intolerance, some level. And if you are of Asian descent, 70 to 100% of people in that community often suffer from lactose intolerance issues. There are other other enzyme-related diseases besides lactose intolerance that could be even more serious. One example would be PKU, and if you have PKU, then you are lacking an enzyme that helps break down a toxin that can build up in your blood that comes from your diet, and it could lead to mental retardation if you don't change your diet. And so every baby is tested for PKU at birth. And if the baby has PKU, they'll be put on a special diet for the rest of their life. Tay-Sachs is another disease that's even more tragic and leads to infant or child death in almost all cases. In this case, the babies or the children are born lacking an enzyme that causes toxins to build up in the spine and in the brain, and eventually they will show changes in their development, and they'll die by ages 4 to 5. So that was a lot of information about enzymes that you might want to add to your brain dump page. So it's time. Get out your brain dump sheet and let's start dumping. Remember, you can always rewind the video, watch it again, pause it, add information. Remember, our essential question is, how does this relate to Maria?